Hey, welcome to Chapter 6, Lesson 3, Rotations. Our learning target or objective for this lesson is to graph rotations on the coordinate plane. Let's have a couple definitions for this one. Our first one is rotation, which is a figure is rotated or turned about a fixed point. And our other vocab word is center of rotation, which is the fixed point. Okay, we're just going to get right into our key concepts for this lesson. Okay, and words. Rotation is a transformation around a fixed point. Each point of the original figure and its image are in the same direction, same distance from the center of rotation. And then here are models. The rotations shown are clockwise rotations about the origin. Okay, sometimes that's important. Sometimes our rotations around the origin or the center of our graph, or sometimes they're around a vertice or one of the points of a figure. So that's a key concept. Okay, so our rotation, look at our 90-degree rotation. It's rotated 90 degrees clockwise. And look at the symbol. When we're rotating from the center, from the origin, our symbols are XY, then Y, negative X. These symbols, you can only use them when our fixed point is the origin, not a vertice, but the origin. Keep that in mind. Okay, our 180 degree, our vertices X and Y of our pre-image, then our image becomes negative X, negative Y, so they're the exact opposite. And then our 270 degree rotation, our vertices, our pre-image vertices X and Y become negative Y, X. Okay, up here written, just in case some of you might need to know, when we talk about clockwise, hands of the clock always go to the right. Or you might see CW, that means clockwise, goes to the right. Or you're going to hear the word counterclockwise. Or you might see CCW, that goes to the left. It goes counter, opposite of the clock, counterclockwise. We're going to take a look at a couple examples. Our first example is going to be centering on flipping a desk, and the fixed point is going to be one of the vertices. So here's what you need to do when we're rotating off a vertex. First, we're going to graph our triangle, 5, 4. That becomes L, that's 5, 4. M is 5, 7. That's M, that's 5, 7. And then N is 8, 7. 8. Okay, this represents a desk in Jackson's bedroom. Let's make the desk. Let's connect our points. Okay, he's got a triangle desk. He wants to rotate the desk counterclockwise, 180 degrees, about the vertex L. L is not going to be moving, and that point of the desk is going to be the one, our fixed point. And counterclockwise, once again, counterclockwise, we're going to the left. So this is moving. It's moving 180 degrees. We know a straight line is 180, so this line is going to be flipping directly that way. When rotating on a vertice, all points remain the same distance away from that vertice. So let's look at M. M is 1, 2, 3 spots away from L up, so it's going to be 3 spots away from L down. 2, 3. So that's going to be M. M's new spot is going to be 5, 1. Okay, and now N. N is going to once again go 180 degrees. So it's going to just rotate this far over here. And look at it is 3 over and 3 up. So it's going to be 1, 2, 3 over to the left, 2, 3 down. This will be N. And his new coordinate is 2, 1. So now we're just going to draw our new desk. And there you have our desk rotated 180 degrees counterclockwise. Okay, we're going to do some more examples in class as well, but if you need more work, you can always replay the video, look it over. But just remember, when you're rotating around a vertice, the one vertice is the fixed point that stays the same. The other ones that move remain the same distance away from that vertice. Okay, let's take a look at our next example. Triangle DEF has vertices there. Graph the figure and its image after a clockwise rotation of 90 degrees about the origin. Give the coordinates of the vertices. Okay, let's graph our triangle. Negative 4, 4. There is D, which is negative 4, 4. E is negative 1, 2. That's E. And F is negative 3, 1. F is negative 3, 1. There is our triangle. We'll be rotating it 90 degrees clockwise about the origin. So we're going clockwise, we're going to the right. The origin is right there. So we can always take a back look at our key concept. Our key concept told us that our original, here's our pre-image points, and then you go y negative x. What that means is our words are, we're going to flip spots around. So let's look at E. E is two negative 1. So now E prime is going to become 2, 1. Because you have negative 1 is the x, but then it's a negative as well, so it's going to become a positive. So E is going to become 2, 1. So E is going to be right there. That's going to be E, 2, 1. Let's look at D. D prime. D is going to become 4, 4. There's going to be D right there, 4, 4. And F. F prime, our new one, is going to become 1, 3. And that is flipping at 90 degrees. As you see, there's a 90-degree angle right there, 90-degree angle right there, and 90-degree angle right there. They're all 90-degree angles. If you match up the old vertice with the new vertice, they're all 90-degree angles. And that's how you rotate around the origin. Okay, going back, we don't have an example for you to finish for class today, but we do have our graphic organizer. Once again, define in your own words. And 3 characteristics about rotation. And then draw an example of a rotation and a non-example of a rotation. And this is the end of lesson 3.